Hello guys, welcome once more to another video in our YouTube channel. So in today's video we are going to be looking at a very technical problem. Now the problem reads, show that x plus 1 on x is always greater or equal to 2 for every positive value of x in a set of real numbers. Alright, so I'm going to present two methods. One, we are going to kind of study the function x plus 1 on x, and we show that 2 is its minimum value. Then the second method will just basically use some basic principles, which in maximum 2 lines we are going to be done. Let us start with method 1. So I'm going to let f of x to be x plus 1 on x. Now to study this function, I'll need to get a derivative, so I try to find either the minimum or the maximum turning points. Alright, so the first derivative will differentiate x, we get 1. We differentiate 1 on x, we get minus 1 on x squared. Now if we do the second derivative, we differentiate 1, we get 0. We differentiate minus 1 on x squared, we get 2 on x cubed. Now we are going to know why the second derivative is going to be very useful. Now let us first of all simplify the first derivative so that we can easily find the stationary point. So if we simplify, we are going to have x squared minus 1 all divided by x squared. Now we know that the first derivative is 0 at stationary points, so equating it to 0, we just have to equate the numerator to 0 since the denominator cannot be 0. Doing that, we are going to solve for the values of x. We have two values of x equal to minus 1 and x equal to 1. But we realize that we are dealing with positive values of x, so we have to reject negative 1. So the only value of x that will satisfy this equation in this interval is x equal to 1. Now x equal to 1, how are we going to use the second derivative? Our second derivative test actually tells us if a stationary point is minimum or maximum. Now if the second derivative is of a stationary value is positive, then that stationary point is going to be minimum, and if the second derivative of the stationary value is negative, then that stationary value is maximum. If I do f double prime of 1, because 1 is our stationary value, right? F double prime of 1 will give us 2 on 1 cube, which is 2, and since 2 is positive, it therefore means that for x equal to 1, the stationary value is actually minimum, so it has a minimum turning point at x equal to 1. Now what is the corresponding y coordinate of that point where x is equal to 1? We just have to look for f of 1. Alright, and in essence, since f of 1 is actually the minimum turning point, the minimum value, because when x is equal to 1, the value corresponding to x equal to 1 is f of 1, and that is a minimum value, and a function will always be greater or equal to its minimum value. Alright, because the minimum value is the smallest value the function can take. So for any value of x, the function will either be equal to its minimum value, and as well is going to be always greater than its minimum value. That's why we have the function is always greater or equal to its minimum value for x in the interval 0 right up till plus infinity, with 0 being excluded. Alright, so if f of x is greater or equal to f of 1, what is f of 1? F of 1 is 1 plus 1 on 1, which is 2. So at the end of the day, we can conclude that f of x is always greater or equal to 2 for all values of x in this interval, which takes us to our proof. Now in the second method, it is very short. Alright, so we are going to begin with the basic principle that for any value of x in the set of real numbers, not necessarily a positive real number, in fact for any value of x you can think of that is a real number, whenever you take x minus 1 all squared, the result will always be greater or equal to 0, because we are squaring the quantity. So regardless of the fact that x minus 1 could be negative, once we square it, the result will always be greater or equal to 0. It will be equal to 0 when x is equal to 1, and will be greater than 0 when x is not equal to 1, when x is any other real number. Alright, so from here we are going to expand the left hand side. We are going to have x squared minus 2x plus 1, then greater or equal to 0. I'm going to move 2x to the right hand side. I'm going to have x squared plus 1 greater or equal to 2x. Now from here I'm going to divide all through by x. Now with the condition that x is a positive real number, I can divide all through by x, and my inequality sign will still remain as greater or equal to, because x is positive. If x was negative, the inequality sign is going to reverse, and since x cannot be 0, definitely we can divide by x. So dividing all through by x, x squared on x is x, 1 on x is 1 on x, 2x on x is 2. So at the end of the day, we definitely have proven that x plus 1 on x is always greater or equal to 2. Thank you guys for watching, and see you in the next video.